Hey guys, I figured I would make a video to help you out in Chapter 1. So this is Chapter 1, Quiz 1, for lessons 1-1 through 1-4. So we're going to start working with expressions, and then we'll get into equations, and then we'll get into inequalities. So when we're working with expressions, one of the biggest things to remember is that we have to combine all like terms. So up here we have three different expressions. We have a y expression, an n expression, and an a expression. We see we have a variable term and a constant term inside the parentheses. When we're working through solutions or simplification or anything like that, we're always thinking, what can I do? Order of operations determines what I'm allowed to do. So PEMDAS, that parentheses, exponents, and really parentheses we should call grouping. But grouping symbols, exponents, multiply, divide, add and subtract, multiply, divide happen at the same time, add and subtract happen at the same time. So I can do nothing in here because I can't combine these, they're not like terms. I would distribute my negative and I would get negative 7y minus 12, or you could say plus a negative 12, but that's a little bit excessive, so we don't normally say plus the negative, we normally say minus. Here my 2/3 is going to distribute, so I'm going to take 2/3 of the coefficient value, so 9 is my coefficient here, 2/3 of that is going to end up being 4, and sorry, no it isn't. A third of 9 is 3, 2/3 of that is going to be 6, so we get 6n, then minus the negative. Well, we actually could have already simplified that before we started. This minus a negative is actually going to tell me plus, so that 15 is really positive, and 2/3 of 15 is 10, so we get plus 10. Regardless of where the value up against the parentheses is, we have to distribute that multiplication. So this 1/5 is multiplying into that parentheses even though it's on the back side. So we distribute that in, and 1/5 times the negative a is going to give us a negative 1/5 a. Sorry, that a kind of looks like a 9. Fix that there. And then 1/5 of 100, well 100 divided by 5 is going to give us 20. There's no sign change on that, and that is how we deal with those three expressions. All of this is going to be captured into a PDF document, so it should be posted in the Chapter 1 folder. I think I'm calling it Math 1 Solved Problems, Solving Equations and Inequalities, something like that. So now we actually have equations where we have one expression equal to another expression, and we still want to think through what kind of terms do I have. Are they variable terms, constant terms? Can I group any terms? So I have a constant term, a variable term, and a constant term. So really, when I start thinking about this, I got to choose a side to be my variable side, and I have to choose a side to be my constant side. I only have a variable on the right-hand side. So to me, this isn't right way versus wrong way, but to me, it makes sense to leave the variable there and get rid of the constant here. Now the one issue, and the one discrepancy that some of my math friends like to say, is then I'm going to make a value negative, and that's kind of annoying. So there are two ways to solve this, and I'll show both ways on the first one because it's kind of easier. So way one we'll do in red, I guess. If I subtract 69 from both sides, then 45 minus 69, difference between them is 24. So this is going to give us a negative 24 is equal to 3b. Now the other way that I could do that, guess I'm going to do it in blue. Ignore number 5, but I'm going to move over here. 45 is equal to 3b plus 69. Now, this is a little bit longer, but some people like it because you keep your constant values positive. If I move my variable value over to the other side, I do that by subtracting 3b. So yes, this does become negative, but watch the process that happens. I have a positive 45 minus a 3b equals my positive 69. So now I'm going to get rid of this 45, and since it's positive, this minus has nothing to do with the 45. This 45 is positive, so we subtract 45. That then gives me negative 3b on the left-hand side. You got to bring the negative with it. 69 minus 45 gives me that 24. Now, regardless of which way I solve this, I'm still going to get the same answer. Here, to solve for b, I would divide by negative 3, and I would get that b is equal to negative 8, because remember, when there's one negative, my value is going to become negative. When there's pairs of negatives, that pairs up to make a positive. Over here, I divide by a positive 3 to isolate my variable of b, and I get, again, negative 8. So regardless of which way we take for number 4, whether you make the constant value negative or whether you make the variable value negative, you're going to end up with the same solution. Moving on to question 5. We have a distribution that needs to happen before we move on. So I actually am going to zoom in so I have a bit more workspace here. So anytime you have a situation like this, again, you have options. So I just kind of misspoke a tiny bit. We have a distribution, but we don't have to do the distribution. So first, I'll show you the way with the distribution, then I'll show you the way where we don't distribute and instead do the opposite. So we'll do first way in blue. If I distribute my 1/3 out, so I get 1/3 C minus, and this would be 2/3, easiest way to write it, equal to 7/3. That then needs the constant values combined because I've got variable, constant, constant. So to combine the constants, and I really like changing color when I'm doing something on both sides. I didn't do that in the last problem, but if you have multiple colors to work with, it helps activate your brain to see what's going on. So 1/3 C now equals 9/3, which we could obviously simplify to 3. But then if we have 1/3 of C, what do I need to do to that third to get C to be a total 1C? Well, I need to multiply 1/3 by 3. So over here I multiply by 3. Well, I know that this division by 3 and a multiplication by 3 is going to cancel out. So that gives me just the final value of C being equal to 9. Now, if I want to solve that a different way and not distribute, which sometimes our fractions don't work as well, and the distribution is going to make things really messy. So instead of distributing, just like we did in that last step there where we finally multiplied by 3, what if we start this process by just multiplying by 3? So that multiplication by 3, and I have to do it on both sides, that gets rid of the division by 3, or gets rid of the 1/3. And sorry, I shouldn't really say get rid of. It cancels out to 1 because it makes the value whole. So 3 over 1, same thing as 3, times 1/3. These reduce out to 1 or cancel out to 1, whatever you want to say. This division by 3 and this multiplication by 3, they do the same thing. And I'm left with C minus 2 equals 7. Then to solve that, it's really easy. I can just add 2 to do the opposite of the subtraction, and we will get that C is equal to 9, the same value that we got before. Now, it's up to you which way you really think is easiest. I think this way is easiest, because then I'm not working with fractional values. I'm not distributing with a fraction. If there was anything in here like a 5 or a 7 or an 8, I mean, thirds don't work very nicely. So if you understand this process, hopefully you've learned that in 8th grade, but I really think this is the easier process to avoid distribution. Moving on to problem 6, we get slightly more complex here. So what is the solution? Sorry, this one isn't really much more complex. Now my variable's on the right-hand side, and it has a negative value with it, or a subtraction with it. So again, identify we have constant, variable, constant. I'm going to go ahead and leave my variable term on the right-hand side. So what I'm going to do to start is add 3 to both sides. That compensates or undoes the subtraction of 3. Half of V is equal then to 8. Well, half of what equals 8? You might be able to rationalize out that that's going to be 16. Otherwise, I can double this, because double of a half is going to leave me with just V. And when I do the same thing on this side, because whatever I do on one side, I have to do on the other side to keep myself balanced, I end up with V equals 16. And again, you should know this from 8th grade, but if I'm curious if my answer is actually right, I can plug it back in. Half of 16 is 8. 8 minus 3 does come out to be 5, and that is going to be our solution. All right, so as we get to problem 7, it looks a little bit complex, but what we want to notice first is I have 2 variable terms on the same side, so I can combine those because they're like terms. I can also do the distribution of 10, and that's going to work easily with the x and the half, so I'm going to go ahead and do the distribution. So on the left-hand side to start, I get 10x, half of 10 is 5. 3x plus 7x is also going to give me 10x plus 5. Well, this is interesting because I have 10x plus 5 on the left side and 10x plus 5 on the right side. So you might already have seen these situations. Hopefully you have in 8th grade, but if not, watch what happens when I start to try to combine all my like terms. I subtract 5 from both sides and end up with 10x equal to 10x. Hopefully, you start to see where we're headed with this. If I divide by 10 to isolate the x, and divide by 10 to isolate the x, I just get that x is equal to x. So, if x is equal to x, well, what if I plug in 3, or 4, or 12, or 8,720? Any of those values are going to work for x. This is an identity equation. So essentially this equation is saying I equal myself. This is a different form of myself, but 10x plus 5, 10x plus 5, they simplify out to the same thing. Any real number will solve this equation. So this is an identity, or you could also write all real numbers or any real numbers. When I was in school, we got taught to abbreviate it as ARN, for all real numbers will satisfy that equation. Moving on to number 8, we see that it wants us to start with a division, but we don't have to. Because I don't really want to divide n by 2 because I don't know what n is. And dividing 1 by 2 is just kind of annoying because then I'm going to be working with fractions. So instead of doing the division, I could just do the multiplication and never have to divide. So if I multiply by 2 and multiply by 2, sorry that I'm writing on top of the 8 right here, that multiplication by 2 on the left-hand side compensates the division or stops it from happening. So I just have n minus 1. My right-hand side becomes 34. Now I see that to isolate my n, all I have to do is get rid of this minus 1. So I'm going to add 1 to both sides. And we get that n is going to be equal to 35. And again, there's just one solution there then, as opposed to in 7 where all values worked. Now, if you're really algebraically minded, the beginning was probably easy, just working with the numbers and the variables. But as we get to the situations where you have to create the equation on your own, some people start to struggle because we have to identify what's the variable and what's the constant. So I'm going to look for variables and highlight them in yellow. So the total cost for 8 bracelets, including shipping, was $54. Shipping charge was $6. Well, what was the cost of each bracelet? So here's what I don't know, is the cost of each bracelet. What I do know is we ordered 8 of them. We also know our total fee was $54. And we also know that the shipping charge was $6. So I always talk to my students about what happened multiple times, what happened once. Well, I paid the shipping charge once, and I bought multiple bracelets. So as I go to set this problem up, you can either start with the variable term or start with the constant term. I like to start with the variable term. So my variable term here, 8 bracelets, I'm just going to set up 8b plus the fee for the shipping of $6. That totaled my 54. Now that we have this, really the question I want to ask first is, what did I pay without shipping? What did I pay for just the bracelets? So if I get rid of the shipping fee and I look at just 8b being equal to 48, that's telling me I paid $48 for those 8 bracelets. Nothing else is coming to play there, just bracelets. No shipping, already took care of that. So if this is the total charge for 8 bracelets, and we assume that they all cost the same thing, then we can just divide by 8 to find our unit price. You remember, unit price is the price for one of something. So 48 divided by 8, this is almost easier if you think about it from 40 and then 8 if you don't have your multiples memorized. So how many 8s fit into 40? Hopefully you know that's 5. Then one more 8 gives me 6. And we know since this is the cost for bracelets, our label on that would be that each bracelet is $6. Now another thing that we could do, if we're saying that each bracelet is $6, is say, okay, well, if this is the cost of one bracelet, then really I have 9 6s here, because this is 8 bracelets, and if they're $6, I have one more 6. Does 9 6s equal 54? You betcha. So back in my day, we we're kind of living in the era of music downloading becoming like this really cool, prevalent, popular, and sometimes dangerous thing, because people would use websites like Napster and Kazaa and all these things to illegally download music. Fortunately, these days we have legal ways to download music, and it's pretty affordable. What I always wished for when I was a kid was a website where I could listen to all the music that I want, but not necessarily own any of it. Spotify. I love Spotify. So if we compare these two things, I really think of this situation as like iTunes versus Spotify. Now, don't jump down my throat if I'm speaking incorrectly because I don't use anything Apple. But I'm pretty sure on Apple Music, you got to pay a monthly fee, and then you got to pay a per song fee. So if I set up my equation and say I pay $10 monthly, well, this is going to be in a situation for one single month. So how many songs would you have to download from the first store for the cost to be the same? Sorry about that. For the cost to be the same as at the second store. So if we look at just a month, the $10 is only going to happen once, plus however many songs I download, that would be 1S. I want that to be equal to my other store, which is just $30 for the month. I can download as many songs as I want. So this is kind of easy because they made the variables nice to work with. 10 plus 1 times something is going to equal 30. I'm going to walk through the solution process, but a lot of us probably reasoned out at this point that this needs to be 20. So if I subtract my constant values to combine those like terms, I get 1 times S is 20. Well, 1 times anything is fairly redundant, so I can just say that S is equal to 20. And that tells me that if I download 20 songs from my Apple Music at $1 a piece, that will level out to my other subscription cost, which Spotify is not $30 a month, fortunately. That's how we would do that. And with how much music you probably listen to, I would say go with the second music store. So when we think about the next question asked here, if we only download 15 songs a month, well, we just saw in the problem above that 20 songs make the cost be equal. So think about if I'm getting $1 per song, or if I'm paying $1 per song, if I only download 15, that's $5 that I don't need to spend. But on the second store, I'm spending that money regardless of how many songs I download. So store 1 would be the better option if you're only downloading 15 songs, or really if you're downloading 20 songs or less, you might as well go with store 1 because at 20 songs it's equal. Anything less and you're going to save money. Moving on to problem 11. Clear that. I do that often. There we go. Moving on to problem 11, we again want to solve. It says find the values of m for each value of n. So we're going to plug in these values and then determine our solution. So one really easy way to do this is find what m is relative to n, so that then I can plug it in. So essentially what I'm saying is isolate m right now, even though there's multiple variables involved. So over here, how do I isolate the m? Well, I want to remove the minus 9n. So first I'm going to start by adding 9n to both sides. I like to use red for that. So if I add 9n and add 9n, I get 3m equal to 24 plus 9n. Then I still further want to isolate my m, so I'm going to get rid of the coefficient of 3. Apparently I'm popular this morning. I'll deal with that in a minute. Coefficient of 3, division by 3. So, m, now when I divide by 3 on the right-hand side, I have to divide by everything on the right-hand side. So the 24 gets divided by 3, and the 9n gets divided by 3. So this is going to become 8 plus 3n. From there, we can plug those values in and finalize our 3 different values that I'm going to get for m. I'm not going to walk through that step because that is fairly straightforward. All right, took care of the phone calls. The one was my mom. Always call your mother back. So, -2 divided by -6. Or, sorry, I got to set this problem up. Over here, we isolated m. We can plug in n. We can find the different values for m. We want to do the same thing here. So I already showed out the process. We take away the 4n to work towards isolating m. But then we're left with a -6m. You got to be very careful. One of the most common mistakes that I see people make is they forget to take the negative along with it. That negative is part of the 6m. So really what we're saying is the -6 is part or attached to the m. So to isolate the m, we got to get rid of the -6. It's multiplied, so we need to divide. When we divide by the negative, we are going to divide by every value on the right-hand side, which means I'm going to first take -2 divided by -6, and then I'm going to take -4 divided by -6. One rule that you have to remember is a negative divided by a negative makes a positive. So 2 divided by 6, that can reduce out to 1/3 and it becomes positive. 4 divided by 6, I'll deal with the n in a second, that can reduce out to 2/3. Those are both negative, so it becomes positive. And I get 1/3 plus 2/3 n. These cannot be combined. Please do not try it. They are not like terms. So then I would take my values for n, plug those in, and I would get my different solutions for m. All right, so now we're asked, this is doing something weird. Let me pause this for a second. All right, back to normal. So now we're asked to solve for x when we have 3 different values. So I have d, f, and fx. Be careful because as you get up into math 2 and things, we'll use functions that are in notation f of x. This is not f of x. This is just f times x. So we don't know what any of these values are, but we need to isolate the x. So the first thing I need to get rid of is the value that is not like directly attached to x. So through arithmetic, addition or subtraction, this f is able to be gotten rid of or moved to the other side. So I am just going to subtract f from both sides. Now realize, think about like what a value for f might be. If f was like 3, this would be 3 plus 3x, which have nothing to do with each other. One's constant, one's variable. So when I subtract that, my left-hand side, well, I can't combine the d and the f, so I get d minus f equals fx. Then to isolate the x, I got to get rid of that f, so I divide, sorry, not by x, I divide by f. And over here, again, we divide everything on that side by f. So when I now have x by itself, I had the d divided by the f, and then minus is still there. F divided by f, any value divided by itself is going to be 1. So we get d divided by f minus 1 is the value of x. As soon as I know what d and f are, then I can go ahead and solve for x. We're going to do the same process here for x where it's in the numerator. Since it's involved in a division, the first thing I want to do is get that division to not happen. So best way to do that, multiply. Reverse the division with the inverse operation of multiplication. So luckily on the left-hand side, there's only m, so I just get pm equals x plus n. So again, we're solving for x, isolating that value, so we then need to get rid of anything else attached with the x, which is the n through addition. So I subtract, and I then get x will equal pm minus n. To solve that x value, I would need those other 3 variables, p, m, and n, before I would be able to figure that out. And the last problem here on our quiz, if a rectangle has a perimeter of 160 feet and a length of 55, what is the width? Start by writing the formula and showing all steps in solving the equation. So first thing you need to think about is a rectangle's perimeter comes from, I'm going to set up our generic formula up here, 2 of the length and 2 of the width. From there, we know that the perimeter is 160. We can plug that in right here. We know the length is 55. We can plug that in right here. And we don't know the width. So I get 160 equals 2 times the 55 plus 2 times the width. I know that 2 times 55 is 110. So I get 160 is equal to 110 plus 2w. I'm going to shift over left a little bit because otherwise I'm going to end up blocking this. So I get rid of, sorry, that's 110. Get rid of your constant value to work towards isolating that variable. So we subtract 110 from both sides. That leaves me with 50 must be the 2w. And to isolate that w, it's multiplied by 2, so I want to divide. And we get that w is equal to 25. We don't have units, so we can just put a U for units. That is it for this quiz. I am going to stop this video, and I will post a second video for the quiz number 2 for Chapter 1. If you still have any questions, comments, or concerns, please contact me before you go to take the assessment for Chapter 1. We want to make sure that you're solid and understand all of this so you can do well on that assessment and keep moving forward. Have a great day, guys.